Okay. Today we're going to try to do in this week this learning activity. Again, we're looking at NP complete problems and how and what they are kind of. Uh, Tuesday we kind of looked at what NP complete is. So these are we looked at polynomial time problems, and these are not non-polynomial time problems. These are non-deterministic polynomial time problems. So problems that are very close to polynomial time, but not polynomial time there. So problems that we could, if we knew a solution, we could verify this solution in polynomial time is another way of thinking of them. And I wanted you to kind of get to know some of these problems. And so we're going to do that today. So for the learning activity, I have a list of 20 NP complete problems, and your job is to pick one of these and kind of do a deep dive on one of these. Every student's going to pick a different one here. So we'll want you to pick one of these and put your name in this column here to show that you want to research that. And we'll talk about these a little bit. So that's going to be one of our jobs. And then you'll do this worksheet on it. So what you'll have to do is go in here to this learning activity. You'll want to edit this main one, and you can edit this and put your name on one of these problems to pick. It's first come, first serve here. Put your name under one of the problems, and then make a copy of this worksheet. At least make a copy of this second part of the worksheet of what you have to do here. So you pick a problem here. You're going to put your name of the problem, an overview of the problem, walk through the problem, give more details of what this problem actually means there. And then we're going to show that this problem is NP complete. And if you remember, there's two parts of that. First, to show it's NP, which means show that there exists a polynomial time algorithm that can verify whether a given potential solution or a certificate is what they're often called, has, for an instance, a P is correct. So if you're given a solution, can you verify that solution in polynomial time there? So for example, the traveling salesman problem, you're trying to find a path for a delivery truck to drive around and visit every location only once here, and you want it to be the shortest time. So can you verify that in polynomial time if you're given a solution to that in polynomial time? So that's the first part. So that's all focused on your problem here. And we're calling that problem P. Your problem is P. I guess maybe I shouldn't have said pick P because that's not polynomial time, but that's just your problem. And then you're going to work on two other problems, related problems. So you're going to pick another problem so the other thing we have to do to show that your problem P is NP complete is show that we can reduce some other known NP complete problem to your problem. So again, you're going to pick another problem. It can certainly, I suggest, it'd be nice if it was a problem in this list here, but it doesn't have to be. Also, if there's some NP complete problem that you're really attached to that's not in the list, I mean, you might have your favorite NP complete problem at this point. Like you have your favorite color and your favorite polygon. You can add that to the list if it's not there. But for this, you're going to pick a problem, and again, well, hopefully it'll be in the list. Otherwise, we should add it to the list. And we're going to call this problem A, and you're going to give the name of problem A, an overview of problem A, and then we want to show that P is NP hard. So we're going to show that problem A can be reduced to problem B problem P in polynomial time. So can we reduce this problem? So maybe like if you're doing the traveling salesman problem, for example, you'll want to do some research, and often the Hamilton path problem or the Hamilton cycle problem, they're both very closely related, but one of those can be used to reduce to the traveling salesman's problem because they're very close to each other in some way there. So you would maybe pick one of those, describe it, and then again describe how that problem A can be reduced to your problem. And then last is an extra thing. So now we've shown that your problem is NP complete. You want to show that you can do stuff with this, and you're going to show that you can reduce your problem to another problem. So you're going to find another problem in this list or another problem in NP complete and show that your problem, so describe this third problem, problem B, and give an overview of that, and then show that B is NP hard by showing that your problem P can be reduced to problem B. I developed this in here. Let me try to explain the thinking here. In NP, we often make these little charts of, oh, if you work on the click problem, you can reduce this 3-SAT problem to the click problem. And if you have the click problem, you can reduce that to the vertex coverage problem there. So often when we find a problem here, we first have to figure out what we can reduce to get there, but also we say, okay, now we have that, what can we reduce that to? And we make this sort of graph. And so we're kind of make a graph, like this is only a graph of a handful of these problems. We're going to try to make a graph of more of these problems using all of you, and we're going to do this asynchronously. So each student is going to pick a problem. Again, this will be your problem P. Problem A is the one above it that will reduce to it, and problem B will be the one after it that you reduce to. And then once we're done with this, we'll create a little chart showing how this works. So that's what you want to do here. I would like if you could set up your descriptions kind of like this. I was trying to redo this table to do that, but with your name, below your name, can you also include problem A? Here, maybe what I'll do is I'll just put this up here and problem B. And what problem you're going to work on so we can see that. Okay, so that's what we want you to put your name, and below it put problem A and then your link to your work and problem B. Now, one way you're allowed to cheat or to work together, you don't have to work together, what way you can, but if you are doing one problem and you are reducing it from taking another problem, reducing it to your problem, if you know someone in the class who is doing the opposite, you can work together with them or use their resources and stuff like that there. So if, like Grace, you're doing the graph coloring problem, the K coloring problem. I love the K. That's almost one of my favorites too. Good point. So you're doing that one, and maybe someone else is doing the click problem, and maybe you want to show. Maybe Grace is going to show that the click problem can reduce to the graph coloring problem. Then whoever's doing the click problem, if Grace is using this for their problem A, if someone's doing the click problem, they could use this as problem B there. So that's why you're also going to post a link to your work so that other students can look at that. Okay. Now, just so you remember, not every problem can be reduced to every other problem easily there. So you're going to want to do some investigation, use AI or do some search on the internet. If you pick a problem on what problems you can reduce to this. So like he was doing the longest path problem. You should do some research on what problems can be, what are common examples of something that can be reduced to this, and then what can this be reduced to? What is your problem A and your problem B for this? I was worried this was a little complicated, but it sounded really fun to me. Sorry. Do you understand this? Well, try it out. Pick a problem. Try to find problem A and problem B. So problem A is what you're going to reduce to it, and problem B is what you're going to reduce there. Before I let you go here, I'm going to talk a little bit about the final project here. So you're in this class, you've got to do a final research project, and that involves both a paper of 2,000 words and a 5 to 10 minute presentation here. You have a couple options as far as the paper goes. It can be kind of a traditional research paper. You can summarize current research in a topic from this course. So if there's something you're interested in, like maybe this NP completeness or like primality testing or something else that we covered in this course, you can summarize that. You should probably be pretty specific here. So maybe not do, a final paper on NP completeness, but on an algorithm or a couple related problems or algorithms in NP complete or something like that. So that's one thing you could do. Another thing is you could research an advanced programming technique and basically create an advanced programming tutorial. Pick some, something we've talked about, asynchronous and await stuff, or generics, or lambda functions, or recursion, or something like that. Write a tutorial that includes clear explanation of that technique and example code in 2 or more languages of that. So more of a programming languages type example here. The third option you have is to research a new programming language, do a deep dive into a programming language that you don't know, so you can't do Java or Python. If you don't know Python, I'd let you do Python, but I would recommend doing some language that you have to do some language that you don't know, haven't had a class on, basically, here. And again, I want this to be not just an introduction to the syntax, really kind of look at some of the advanced features in this language and how it works. So look at advanced techniques and how, and you can compare it to our other programming languages, but go beyond just, this is how you do a for loop there for that. So your final paper has to be 2,000 words. You need quality sources. It has to be citations and basic kind of format, should follow APA format. I'm not a big stickler for APA format, so like I generally, and varies when people say APA format, whether or not, I don't need a separate title page. If you want to, you can have it. I don't need an abstract. I don't need double spacing, and I don't need page headers and page numbering, that sort of stuff. But the general layout, especially the way citations are done, are helpful for that. So, oh yeah, I should update this. Let me change. I also wanted to talk a little bit about the use of AI when writing papers. I thought I updated this, but I didn't. Let me just update this. Okay. Here's my suggestion of how to use AI appropriately for this. In general here. So again, this sort of stuff we call writing to learn. I'm not teaching you to write. We're using writing as a true tool to help you learn a specific topic there. And so in that, it's useful for you to actually write uh, stuff. Um, but you can use AI. So, I mean, AI, I think, is really good at preliminary investigation. It's good when you're doing your resources there. I strongly suggest for your first draft, you write your first draft yourself without AI. This lets you set your tone, your style there. Your first draft, you don't have to worry too much about the, grammar, citations, paragraph, that sort of stuff is not as important. Just want to get your thoughts down. And again, this critical thinking is really central to this whole writing to learn method. So again, the writing to learn method focuses on writing as a tool for understanding, critically examining, reflecting, making connections in your topic there. And again, it only really works if you're actually doing the writing there. So your first draft should be written without AI. Your final AI, or final draft, I think AI is good at a lot of things there. But you generally don't want AI just to rewrite your paper. So you should be asking it to some specific questions. So I have some examples of prompts in here. So like, does the paper have a logical structure? Or, what is the main argument or thesis of the paper? Is it clearly stated in an introduction? Is it clearly restated in the conclusion? Does every paragraph contribute to this? Point out sentences or sections that could be clarified, expanded, or restructured, or explain why they need revision without changing the text yourself there. So again, this is a nice prompt that'll have AI help you out without having it rewrite your paper for that. So that's what we want. And you can take those suggestions and update the text for that. And so here's a couple other prompts with those sort of same things. That's my suggestion on how is a good use of AI. I don't know how you use AI, if you use it with writing there, but that's my suggestion at this point. The other thing is that you'll write your paper. You also do a 5-5 presentation. So you do a presentation for 5 minutes, and then you answer questions for 5 minutes. And again, I really want to, the reason we're doing the presentation is to check your knowledge. Did you actually learn, because to tell you the truth, I mean, you could use AI, one of these deep research AIs to do this whole thing for you. It is quite possible to have it right. You can give this instruction, it will do the whole thing for you. So the presentation here is to make sure you are learning something from this stuff. So you sign up for a time to do a presentation. So there's a presentation sign up sheet. Last day of classes is May 11th. You can do presentations there. You can do it on the exam time, May 5th at 8 o'clock. If not many people sign up for that, we could maybe start at 9 o'clock. So there's that option there. Or 2 Zoom sessions here. So again, just pick one of these. So like Addison, if you wanted to, Addison really wants to do Monday, you could just put, say you're going to do it then. So just pick one of these times that you want to do your presentation there, and I'll organize who's ever doing presentations then there. So just put an X where you want. And then you do your presentation 5 minutes, and then I'll spend 5 minutes grilling you to see if you know what you want. I'm not really good at grilling students, so I'm going to give you kind of some of the questions I will grill you on ahead of time. So these are some of the questions out there. What's something new? You should be able to pick. I mean, you've done interviews or you've done these. You should be able to write these questions. I mean, AI could write these questions for you, but you certainly know what these questions are. What's something new that you learned from your research project? What surprised you most from your research project? Describe something you struggled with in your research project, and how did you overcome this? Right. These are standard, faculty questions during a presentation or something like that. So I'll be asking you some of this sort of stuff. And some of them will be specific. So, I mean, you should have source material. I will ask you something about your source, but like which of the source materials do you use the most there, so that I can check that you use the source material and can talk about one of your source materials that you cited there. You should know at least one of those, obviously. So that's your, what are we doing? Questions on the final project presentation stuff? Online students, feel free to email or text me if you have questions there. And remember, online students, is that all the presentations are synchronous. So you can't, in this class, you can't record a presentation and submit the video. You have to sign up for one of these times here. And that's why there are 2 evening times that you can do on Zoom there. All right. Okay, so I'll let you get going here. So remember, go into, pick a problem, figure out what problem can be reduced to your problem, and then figure out what problem you can reduce your problem to here. So again, if you're picking this click problem, you're going to want to find like the 3-stat problem that can be reduced to the click problem, and then you're going to maybe pick vertex covering problem, which the click problem. So this would be your problem P. This is your A is before it, and your B is after it. All right.